In the workshop, small but important jobs. This is a cylinder cover of a steam pump that I bought recently from my friend Don English. And a mistake was made when it was being manufactured, so Don fixed the mistake by silver soldering a blank plug into the hole. Which is okay by me, it's a good repair and it works. I was going to remove the cylinder cover anyway to clean it up with some emery cloth, but I took this opportunity to partially remachine it and get rid of the silver soldered piece that's in there. The repair was required because a hole had been drilled over the steam port, so of course that's no good, there's nowhere to put a bolt. In this clip the cylinder cover is only held by the register that sits down inside the cylinder, and it's very shallow, so I'm only taking very fine cuts. I was particularly careful with the first cuts, which were intermittent as they removed the soldered in plug. And now this side is more or less done. A quick polish with some wet or dry sandpaper, and it's time to turn it over and have a look at the other side. To make sure it's accurate, I'm pushing the cylinder cover into place in the chuck using the tailstock chuck. Here you can see just how small the register underneath the cylinder cover is, and this was all that was being gripped in the chuck when I machined the other side. This job is very similar, I would think, to skimming a cylinder head of an internal combustion engine. And once I finish the underside, I clean the sharp edge. Before finishing this part of the job, I thought I would turn the cylinder cover round and just machine the middle bit like this, for no other reason than I didn't like it sloping too much. In this clip I'm putting it all back together. I've coated the gasket in some gasket compound that I use. Please note though, it is not silicone rubber based. This stuff is very similar to Boss White that's used in a lot of plumbing applications. I don't really need to use it with this gasket because the cylinder head is machined and it's sitting very flat on the actual cylinder. I often like a belt and braces approach. I don't think this is going to leak. When you're tightening such small bolts, these by the way are 7BA, you need to have a really delicate touch. They do need to be tight, tighter than you'd actually think, but beware, if you over tighten them they will shear off quite easily. These vertical 12-inch Southworth pumps are a bit top heavy, the base is small, so I thought it was a good idea to mount it on a piece of wood. I forget where I got this plinth from, it had another engine mounted on it, but I must have taken it off this plinth and built it into a steam plant at some time or other. It was a very simple job to do. I just placed the engine on the plinth where I wanted it, marked through the holes with my scriber, drilled some holes in the plinth, counterbored them from underneath to take some 2BA bolts. So now there's no fear of the engine falling over when it's in steam, just sat on its small base on the bench. When my friend Don built this engine, he left the steam chest cover more or less as it was cast. All the machining and hole drilling is accurate as you would expect it to be, but I just want it to look a bit prettier. The first thing to do is to take off the 12 special brass nuts. Nothing special here, I'm just using a socket for this purpose. With the nuts removed, I'm carefully using a scalpel just to break the seal between the steam chest cover and the steam chest. Inside the steam chest are 3 very important parts. 2 of them are slide valves which admit and exhaust the steam, and the other really clever bit is the shuttle piston. And the gaps between the shuttle piston and the slide valve are intentional. The shuttle piston needs to be really free to move. You get the idea when I move it up and down with a screwdriver. It's very rattly, but this is a good thing. The pressure of the steam holds the slide valve against the port, and with the clearance it allows the shuttle valve to start moving before it starts to move the valve. And this engine runs very well on both air and steam. This casting was very good indeed, so I didn't bother machining it. I thought I can remove what I need to remove on different grades of emery cloth. In this clip I'm using 400 grit wet or dry sandpaper with WD-40 as a lubricant, but I started off with this stuff, 150 grit emery cloth, then 280 grit emery cloth, and finally, as you can see here, 400 grit wet or dry sandpaper. Some of the paint on this engine's become a little bit chipped, so I'm guessing that this is the paint that was used. It certainly seems to be a very good colour match. This is Phoenix Precision Paints P10 Great Western Railway Loco Green. And in this clip I'm touching in one of the chips, and as you can see this is a really good colour match. You can't tell where it's been touched in. I also use the same paint to paint the centre part of the steam chest cover, and it looks fine to me. All I have to do now is refit all the nuts onto the studs and tighten them up, and now I can run the engine again. I'll leave the engine running on compressed air until the end of the video. Thanks for watching, and I hope you found it useful.